Great, so we are looking at day 2 of 3.5, and we really only have a couple things left to talk about. They are going to take a little bit of time, okay, but we only have a couple things to talk about. One of them, very, very similar to what we did yesterday. Okay, very similar to what we did yesterday. Yesterday, we wrote those equations of parallel lines. Right, remember we did that on day 1. So today, we're doing the same exact thing, but dealing with perpendicular. Okay, so the same exact type of question, but it's dealing with, we want a perpendicular line, not a parallel line. Okay, so what is the major difference between what we did yesterday and what we're going to do today? Abbott? Yeah, there you go. So it's going to be the slope, right? Yesterday, the slope just stayed the same all the time. Today, it's going to be that opposite reciprocal. So we're going to flip it. We're going to change the sign. Can I get the slope right now from this? Is it anywhere on here?
Yeah.
Or do I have to do something first?
Yes,
I gotta put it into y equals mx plus b first, right? So I want you to go ahead and do that. I want you to get that into y equals mx plus b, get your slope, get your perpendicular slope, and then put it in the equation. Get that perpendicular slope, use that 0.23 and put it into the equation. We gotta make sure we get the right slope. Okay, so our original slope is gonna be a -2. So our perpendicular slope is gonna be 1/2. I always write it like this. You don't have to, right? But I like to keep it straight and say, all right, I'm taking the perpendicular. That guarantees that I know, or I guess it's a double check to see, did I take that perpendicular rather than just keep it the same. Okay, so when I go back and check the work, I say, all right, I want it perpendicular. I can know I did perpendicular, so I'm on the right track. So yeah, perpendicular slope is 1/2. I know the point. We put that into point slope form. That's y minus 3 is equal to 1/2 x minus 2. Distribute. And then add the 3. We are looking at y is equal to 1/2 x plus 2 as our perpendicular line. So again, just like yesterday. Okay, the only difference is that perpendicular slope rather than the parallel slope. Any questions about this before we move on? Because we got to be able to do this in the next problem too. Okay. So the next type of problem, and this is a big type of problem. It takes a little bit, but this is the only other thing that we need to know today. Is we are finding the distance from a point to a line. Now we found the distance from a point to a line before, but they had always given us the graph of it. They gave us the graph. They said, all right, pick out which one is going to be the distance and then find that distance, and we use distance formula. Okay, we did that a couple sections ago. They don't give that to us now, right? They give us the equation of the line and the point, and we need to find the distance. So just so that we can visualize it, and we don't have to graph it every time, I'm just going to show you just so we can visualize what we're talking about here. I've got my point at 1, 0, and then my graph is going to be, my line is going to be something like that. Okay. So now, what do we know about the distance from a point to a line? What do we know for sure about the distance from a point to a line? Evan? Yeah, we're looking for the shortest distance, and that's when it's perpendicular. So we have to do something with perpendicular. Okay, so this is where that last thing we just talked about comes in. Because what we're going to do is we're going to find the equation of the perpendicular line. Because if we can find the equation of the perpendicular line, that's going to help us determine the length that we need, that distance that we need. So step 1 out of all of this, there's going to be 3 steps to it. Step 1 is to create a perpendicular equation. And we're going to create the perpendicular equation, just like we just did on the last example. Okay, so I would like you to go ahead and do that. I want you to create that perpendicular equation through point 1, 0. I talk to somebody about it, see if they got the same thing, see what they did, if you had something different. Okay, so we plug it in, 2 points low form. The -0 cancels out, 1 distributing does nothing. So we just have y is equal to x minus 1. Okay, there's our perpendicular line. So what that is that perpendicular line right there. Okay, but they're not just asking for the equation, right? We want the distance from the point to that line. What else do I need before I can find the distance? Another point. What is that point going to be here, Troy? Yeah, the spot where they intersect. So I need to find this point where they intersect, right? So we could get it by graphing. That's not a great idea because we don't like graphing. And what if it's a decimal? And we're really out of luck. We need to find the point where those 2 lines cross. How do we do that? Okay.
System of linear equations?
Yeah, the system of equations. System of equation. When we solved a system of equations, that gave us the point where they cross. So we are going to solve this system of equations using our new perpendicular equation and our original equation. So that's step 2. Is to set up and solve the system of equations. We're going to set up and solve the system of equations. Remember, solving a system, unless you want to graph, which again, you probably don't. You got substitution or you got elimination. So I want you to go ahead and solve that system. This is why we've been practicing all along. Okay, in our reviews, either substitution or elimination. Let's get that ordered here. Let's get that solution. Right, tell somebody what you did for that system. Make sure you got the same thing here. Solve it.
It was. Alright, so solve it. Yeah, I was just gonna say, so it would be 2. So that means y would equal to, so y equals 2. Yeah, so that's how there's 3 square root of 10. The distance from
All right, so when we go to solve the system, we got those 2 ways. I'll tell you right now, substitution is going to be easier most of the time. Okay, substitution is going to be easier most of the time because you're going to have them in y equals mx plus b for both. And you can think of it as substitution, you can think of it as transitive property. But if you have x minus 1 is equal to y and y is equal to that, then these 2 things have to be equal to each other. So we can always just set those 2 things equal to each other and solve for x. Okay, we can do that. Now, in this case, this is the one situation where elimination is actually easy. But this is only because we've got a -1 and a +1 slope. If you don't have a +1, -1 slope, then it's going to be easier to do substitution. Okay. But for here, elimination, we add straight down. Those x's are going to cancel. I've got 2y, careful of that. I've got 2y here. Y plus y is 2y. -1 plus 3 is 2. So y is 1. I plug that 1 back in. I get x is 2. So now I've got the ordered pair 2, 1 as the answer to that system. Again, be careful. If you are going to eliminate, y plus y is 2y. Seen that multiple times. Be a mistake. Okay, so that gave us this point, which is 2, 1. And we know this point is 1, 0. So now we're finally to the point where we can find the distance. What do we have to do?
Distance formula.
Distance formula. Go ahead, do distance formula between those 2 points, please.
So 1 minus 2 square root of 2.
Hopefully you remember distance formula by this point. If you've used it enough, but it's there just in case you need it. Round linear is 10. For an answer, round linear is 10.
What's the square root of 2? Gang.
We do our distance formula. Remember, it doesn't matter which x's go or which x goes first, which y goes first. Subtract them in there. Simplify it. You got square root of 2, which is about 1.4. Distance is about 1.4. Now, this is a long process. This one problem contains basically 3 other problems, right? Each one of these steps is its own problem, basically. All right, create perpendicular equation. Well, that's the last example we looked at. You're going to see questions on the homework that just ask for that. Questions on the quiz test that ask just for that. Solve a set up and solve system of equations. We know that's a type of problem by itself. Distance formula, that's been a problem by itself. And now you got to do all 3 correct just to get one problem right. Okay, that's a lot. That's a lot. Now on the test, that'll be worth multiple points, right? So if you at least got the perpendicular equation right, I'll give you a point. If you can solve the system, I'll give you a point. If you can do distance formula, I'll give you a point. So you got to keep working through whatever you got. Now, if you get the perpendicular equation wrong, well, then everything else is going with it, right? So we really got to focus on these questions to get it all right. Okay. We're going to try one on our own. Okay, I'm going to have you try one on your own, and then we'll be done. Okay, so one on our own, and we'll be done. Use that. Use what you have in your notes, and hopefully you have that in your notes now as an example, and go off. Here's what we're looking at. Number 7 here. Find the distance from the point -1, 6 to the line y is equal to -2x. And if you want to talk through it with somebody as you go, that's fine too. Okay, either on your own or with the person next to you, that's fine. So let's see if we can get that answer.
Yes.
You're stuck, you don't know what to do, ask somebody around you.
You stuff read. How? Easiest thing. This is why. How we ain't done.
You're good, keep working.
Don't be showing us
I'm
answers.
gonna work through here too.
Stricken. Who are we rounding to?
10.
Is it one? Yeah, baby.
Working through it. Yeah, there is.
Yeah. This be like an extra credit question.
This would be a question.
Oh, I see what I did. Oh.
You're gonna see this 4 times on the video.
What?
I guess I'm fast at doing this. That's
This
12
would be a
questions.
regular credit question.
That's 12 questions.
So what's the extra credit?
Yeah.
Yeah, if that's normal, what's the extra credit?
I don't remember.
Well, shoot.
I mean, it could be this one's harder.
What's the distance?
Alright, so let's take a look. Okay, I know a lot of us are there, some of us are still working. Well, let me talk through it. Okay, look at your work versus my work, and trust me, guys, you're gonna wanna show work on this stuff, right? You're gonna wanna have stuff down, don't try to do this all in your head. It's not gonna go well. Okay, so we started with the equation -2x, slope of -2, perpendicular slope is 1/2. So we take that 1/2 to the point -1/6, we plug it into our point slope form. We got point slope form here, I distributed the 1/2, I added the 6 over to get y is equal to 1/2 x plus 6.5, or 6.5. That's our perpendicular equation. Once I have that, I take that and the original equation, and I solve the system. To solve the system, you could do elimination if you like multiply the top by 4. You could do that, but it's gonna be easier just to set up substitution. Set the 2 equations equal to each other. We're subtracting the 0.5x, dividing by the -2.5 to get a -2.6 for x. I take that -2.6, I plug it back in, -2 times that is a +5.2. So my point of intersection there is -2.6, 5.2. My original point they gave us was -1, 6. I'm using distance formula between those two. I did -1 minus a -2.6, so that's add 2.6. You get 1.6, subtract here to get 0.8, you see the rest. Square root of 3.2, which is about 1.8. It's a lot of work, and I understand that, okay, but it's nothing that you can't do. You know how to do all 3 of these things. It's just a matter of doing all 3 of those things without making a mistake. Okay, easier said than done sometimes, but that's what we're looking at. Okay.
Stay there.